Hey everybody, this lesson is on confidence intervals. So this one is just tricky wording. You got to understand the wording. So before we can explain our example number 21, we need to understand what a confidence interval is saying. Okay, so when interpreting the meaning, the key phrase is to understand it's a confidence. So if we're 95% confident that the true mean is between 4 and 10, what are we actually saying? So hopefully this lesson will break that down. So a 95% confidence interval means that if we were to take 100 different samples of the same size and compute a 95% confidence interval for each sample, then approximately 95 of those 100 different samples will contain our true mean. That's what that means right there. So in practice, though, we select one random sample. We don't do 100 different ones. We select one random sample from the population and generate a confidence interval, which may or may not include the true mean. Okay, so we're not going to have to calculate what a confidence interval is, although that isn't hard, but we do have to understand what it's meaning. Okay, so let's begin with this example here. So we take a survey of 45 people who work in a particular city, and so this would be a random survey. So I forgot the word random, but it's always random, who work in a particular city, and found that the average time it takes to get to work has a 95% confidence interval of 18.3 to 23.7 minutes. To understand what that confidence interval says is we'll look at some common errors that people think, and so these will be like the other choices that they'll try and trick you. So here's a false interpretation. It said 95% of the workers taken between 18 take between 18.3 and 23.7 minutes to get to work. Okay, that's not what that's saying. So while we use a sample to get our estimate, we're no longer talking about the sample. So we're not talking about the particular sample, we're talking about the whole population. So the confidence interval is now talking about all the workers in that city, not just the 45 anymore. So that's a common misconception, that 95% of these 45 workers. Okay, the 45 workers let us get a confidence interval of our whole population right here. Here's another false interpretation. There is a 95% chance that the mean time it takes all workers in the city to get to work is between 18.3 and 23.7 minutes. That's a real common misconception. Let me just move that up right there. So it seems very close to being true, but it isn't, because the population mean value is a fixed number. So it's either in the interval or not. So 95% of the time it's in the interval. The population mean is in there, and 5% of the time it's not. So if we did 100 samples of 45 people and we calculated a 95% confidence interval for each of those times, then what that means is 95% of the time our true mean will contain the confidence interval that we calculate of those 45 people. And the confidence interval will be, different from sample to sample, but 95% of the time it'll contain the true meaning. All right, so what is it saying? So 95% of the time when we calculate a confidence interval in this way, the true mean will be between the two values. Okay, so whatever the two values are that we calculate, and the other 5% of the time it won't happen. So 95% of the time it'll calculate our true mean will be in that interval, and the other 5% our true mean will be outside of that interval. So because the true mean, the population mean, is an unknown value, if we could know it, we'd calculate it, you guys, but we can't, because we can't survey everybody. We won't know if the 5% or the 95% if we're in that, but 95% is a pretty good estimate right there. So we'll say something like we are 95% confident that the mean time it takes all workers in the city to get to work is between 18.3 and 23.7 minutes. Okay, so this is a common shorthand for the idea that calculations work 95% of the time. Okay, so remember, we can't have 100%, so by definition the population mean is not known. If we could calculate the population mean, we would, but we can't calculate everybody going to work and how long it takes them to go to work. It just wouldn't be that a census is 100% of the people, and we couldn't do it. It's just impossible, and it'd be too expensive anyways and too time consuming, so it's just not feasible. So why not calculate a 99% confidence level, or even higher, 99.9? Okay, so it seems to make sense. So to get the confidence level as high as we can, Well, as the confidence level increases, your margin of error or your interval also increases. That means our interval is wider. So I'm sitting here holding my hands out wider right there. So as we get a bigger confidence interval, my spread gets bigger and bigger and bigger. Okay, so it may be that our interval is too large or useless. And so here's an example. For example, what if I said to you, I'm 99% confident that you're going to score on the next exam at 10 between a 10 and 100. Okay, well, how useful is that in predicting your performance? Okay, so it's too big. So sometimes it won't matter, but in the it depends on which case you're talking about. But the example I did right there, 99% confidence level gives us a margin that's way too big. So the smaller the margin of error, the smaller the percentage of the confidence level. So for this reason, 95% is often used for confidence interval. So, and it probably will be on your SAT. All right, so here's example 21. A quality control researcher at Fred's Electronics is testing the life of the batteries in a certain alarm system. The researcher selects 100 batteries at random from the daily output of the batteries and finds out of those 100 batteries, so that's our random sample, and finds that the average battery life has a 95% confidence interval of 324 to 360 hours. Okay, that means that our true average life, which we don't know, 95% of the time, if we did this, calculated 100 batteries, 95% of our time, our intervals will contain our true mean. Okay, so our intervals change from sample to sample right there, but 95% of the time, this interval will contain our true mean. Okay. So which of the following conclusions is the most reasonable based on the confidence level? Okay, so A says 95% of all batteries produced by the company that day have a life between 324 and 360 hours. Okay. So, and then B says, and these are similar, 95% of all batteries ever produced by the company have a life between 324 and 360 hours. Well, both of those are, just slid that up, you guys. Both of those are incorrect because the confidence interval gives information about the true average life of all batteries produced by the company, and we don't know that, you guys. So it says all the batteries produced that day. Well, we don't know the true average life of all the batteries. We just know that if we took 100 samples of 100, size of 100, and calculated a confidence interval, our confidence interval 95% of the time would contain the true mean. Okay, it doesn't mean that all the batteries, the mean is somewhere between 324 and 360 hours. If we calculated another confidence interval, it would change change these numbers around. But 95% of the time, this interval will contain whatever our unknown true mean is. Okay, so A and B are not true. Okay, let's look at C. It's plausible that the true average life of the batteries produced by the company that day is between 324 and 360 hours. Can you see the difference on that? That one seems okay. It's not talking about 95% of all the batteries produced, because we don't know what all the batteries produce, the average lifespan on that. But it is plausible that the true average life of the batteries produced by the company that day is somewhere between that. Okay, let's look at D. It's plausible that the true average life of all the batteries ever produced, the key word is ever produced, and that's not true, by the company that day, because we don't know what the true life of all the batteries ever produced, because this population was taken from the batteries that were produced on that day. So population of all the batteries of the company ever produced would probably have a different lifespan due to the changes in the battery's makeup, or the new and old machines, improvement in production, and there's many other reasons that would change the whole lifespan on that. So choice C is our correct answer on that. All right, you guys, take care.